Now today we are going to study about some application of trigonometry. Now in this chapter we are going to study about the height and the distance. You know that the astronomers are using this trigonometric ratios and its application to find out the distances from the sun, from the planets and the stars. The distances can be found out by using this trigonometry. So in this chapter we will study how to find out the height and the distance of the objects. Now first of all, I want to draw the attention that suppose when we are looking at any object, the object when you look, wherever your eyes which you are seeing, that is the parallel direction which you call it as a horizontal axis. Suppose your eyes here, and when you are looking straight, the direction is this. You call it as horizontal axis. Now when you want to look any object, that is suppose which it is on the top, if I take a tree, if I want to look at the tree, the direction of my eyes will change and this will become my line of sight. Actually my eyes, when it is staying straight, this is the horizontal axis, and when I want to look at the top or top to the object, this will become my line of sight. Hence the angle which is made with the horizontal axis and your line of sight, the tree or any tower which you are seeing, that you call it as angle of elevation. This theta is actually angle of elevation. It is angle of elevation. So we can say that the angle formed by the line of sight with the horizontal axis is called angle of elevation. So whenever object which you are looking which is at a higher level, then your eyes make an angle theta or any other angle, you call it as angle of elevation. Now we come to the next. Now suppose your eyes are looking in the horizontal axis, you are looking. Now you want to look at the bottom. When you are looking at the bottom, your line of sight is this. Your eyes should look this way, but you are looking at the bottom, any object which is lying. So your eyes are again making an angle, that this theta, and this angle you call it as angle of depression. So when an object which is at the bottom or something is lying at the bottom and your eyes are bending down to look at the angle which the eye is making with horizontal axis, and this will become your line of sight. The thing which you are looking at the bottom, that will become your line of sight. So this angle which is made, it is called angle of depression. You will call it as angle of depression, because your eyes which is looking at the bottom is making this. Now this angle of depression, see, suppose if I am making this way the axis, again, so this becomes a parallel to this. This is your ground. Take a line I am drawing parallel to this object, that is your ground. So this angle and this angle, parallel lines are there. It is in the Z form, so they will form an alternate angles. And you know that when the lines are parallel, alternate angles are equal. So this angle of depression, you can just write it here also, but it is compulsory, you have to show the angle of depression. When you are drawing this both lines are parallel and hence alternate angles become equal. Now, so we came across the angle of depression and angle of elevation. Now it's very clear, when any object looking at the top, angle of elevation, and when any object which is at the bottom, suppose a girl is standing on in the building and is looking at the bottom, so she will be making an angle of depression. But when I am standing here and I am looking at the clock which is on the wall, then my eyes will be making an angle of elevation. So now I am taking one example. The angle of elevation of a tower from a point on the ground which is 30 meters away. So see, suppose this is AB is your tower and this is your ground. AB is a tower which is on the ground. This is your ground. BC is the ground. AB is your tower. Now the angle of elevation of a tower from a point on the ground which is 30 meters away. Now this is a point. C is a point where you may be standing and you are looking at the tower. So you are looking at this tower. So this is your horizontal axis. This becomes your line of sight. So angle of elevation is 30 degree. We will make this angle as 30 degree. The angle of elevation of the tower from a point on the ground which is 30 meters away. Now what is, this is a foot. The tower is this, clear, and always you think that we will be dealing with the right angle triangle. The applications will be for the right triangle. Now you see when the tower is on the ground, it is making an angle of 90 degree. So this becomes the foot. And from the foot the distance is how much? It is 30 meters. So first you should identify all the things. So the on the ground which is 30 meters away from the foot of the tower. So always the base which is there is called the foot of the tower. Now find the height of the tower. So you want to find this height of the tower. The first thing, you have already studied trigonometric ratios. You should know the ratios. What ratios are there? That is your opposite side upon adjacent side. Now here we are having opposite side as the side which is opposite to this angle is called opposite side, that is H. And the angle which it is lying is called adjacent, that is your 30. So the ratio of opposite upon adjacent, or you may be saying perpendicular upon base, it is 10. So first of all we will mention that let AB be a tower, AB be a tower whose height is H meter. So AB is a tower, the height of AB is H meter, and C is a point which is at a distance of 30 meters. Okay? So this is the distance of 30 meters. Now this ratio becomes 10. So we will write down 10 30 is equal to opposite upon adjacent, that is H upon 30. Now the value of 10 30 is root 1 upon root 3. So keep the value 1 upon root 3 is equal to H upon 30. Now just you have to solve it, cross multiply it. So H will become 30 upon root 3. You know that in the denominator we don't keep irrational number, so we will rationalize it. H is equal to 30 upon root 3. We will rationalize with root 3 upon root 3. So root 3 into root 3 will become 3. So we will cancel it. So it will become 10 root 3 meter. You have to write the units. So we found out, see, by using this we found out the height of the tower. Now another example I am taking, that is a tree breaks down due to storm and the broken part bends so that the top of the tree touches the ground and makes an angle of 30 degrees. The tree is standing straight. Because of some strong winds, the tree fell down and the broken part just touched the ground, making an angle of 30 degrees with it. The distance between the foot of the tree and the top that touches the ground is 8 meters. So where it is touching the ground, it is making the distance is 8 meters. Find the height of the tree. Now you want to find out the height of the tree. Now we are taking, this is a ground, this is ground, now this is a tree. Now this portion is a tree. If I am taking the tree as AB, I am taking the tree as AB. Now you know that it is perpendicular, so 90 degree. We are dealing with right triangle. Now due to the storm, the tree portion broke from here. I am taking this as M. Now this broken portion came and this weight fell and touched the ground. I am taking it as C. So the angle which it is making, this portion which went this way, it is making an angle of 30 degree. Making an angle with the ground is 30 degree. The distance between the foot of the tree, see now this is the foot and this is the top which touches the ground. The distance between it is 8 meter. Now you have to find out the height of the tree. I want to find out AB. So let AB be a tree. In a right triangle, in triangle MBC, if I am taking MB as H and this as X, so total height of the tree will be, let AB be a tree, total height of the tree will become H plus X. That will be the total height of the tree, AM plus MB, that is H plus X. In triangle MBC, now see the ratio. If I am taking this, see I know this value. So first of all I will solve this. With one value you should know. If I am taking this both I am not knowing. So I will go for this option. So the ratio is 10. In triangle ABC, 10/30, that is opposite upon adjacent, H upon 8. 10/30 is 1 upon root 3 is equal to H upon 8. Now H is equal to cross multiply 8 upon root 3, this becomes your H. This you have got. Now I will find out this X also. Now this ratio, adjacent upon hypotenuse, that ratio is cos, or you can even say base upon hypotenuse. So we will come cos 30 is equal to 8 upon X. Cos 30 value is root 3 by 2 is equal to 8 upon X. Therefore, X is equal to 16 upon root 3. Cross multiply. X will come here 16 upon root 3 meter. Now you want to find out the height of a tree. So, AB is equal to X plus H. That is 8 upon root 3 plus 16 upon root 3. Both we will add, denominators are same. So directly you can write down, it will become 24 upon root 3. Again, we have got root 3, so we will rationalize it. That is 24 upon root 3 into root 3 upon root 3. That will become 24 root 3 upon 3. Root 3 will be 3, that is 8. So you will get 8 root 3 meter, that is the height of the tree. Now suppose root 3 you know, the value of the root 3 is 1.732. You can put that value, and if it is this way then also it's okay, 8 root 3 meter. We will be taking one more example based on this. The example it is, a statue is 1.6 meter tall, stands on the top of a pedestal. Now, pedestal is a stand on which you are keeping a statue. Pedestal is a stand on which you are placing a statue. From a point on the ground, the angle of elevation of the top of a statue, from the top of a statue is 60 degree. You are looking at the statue, angle of elevation means you are looking from top to bottom is 60 degree, and from the same point, angle of elevation of the top of the pedestal, then you are looking at the top of that stand, it's 45 degree. Find the height of the pedestal. So while we are doing these questions, you have to read the question 2-3 times. Now, this is a ground, your horizontal axis. This is a pedestal, the stand we are talking about, pedestal, and on this pedestal there is a statue. This is your statue. So this is a stand. On the stand, the statue is kept. You are standing here. A statue is 1.6 meter tall. So the height of this statue is 1.6 meter. Statue. A statue of 1.6 meter tall stands on the top of the pedestal. So this is your pedestal on which it is. From a point on the ground, angle of elevation. Now this is a point on the ground. You are looking at the top of the statue. From a point on the ground, angle of elevation of the top of a statue is 60 degree. So this angles become 60 degree. From the same point again. Now if I am taking this point as a C, from the same point you are looking at the top of this pedestal. At top of the pedestal, the angle it is forming, it is 45 degree. So again, from the same point, angle of elevation, you are looking here. This angle which it is forming, it is 45 degree. And this, it was 60. Now AB is your pedestal and your AM is your statue. So first you have to very be clear with the figure. If the figure is formed, then the solution is easy. So again, AB is a stand, pedestal. On the top of pedestal there is a statue. Now this is making an angle of 90 because it's perpendicular. From a far away point you are looking at the top of the statue, angle is 60 degree. Then from the same point you are looking at the top of a stand, which is 45 degree. Now let AB be a pedestal. AB is a pedestal whose height I am taking as h. It is h meter. BC, which is the distance you will take, BC is equal to x. Now we will solve with the right triangle, triangle ABC. In triangle ABC, this triangle we are taking, the angle is 45. Again this ratio, opposite upon adjacent is 10. So the ratio becomes tan 45 is equal to h upon x. Now tan 45 is 1 is equal to h upon x. Therefore x is equal to h. This you can give it 1. Yes, so you cannot take this triangle as this triangle is not a right. So we will go for this triangle, triangle AMBC. In triangle MBC, the whole triangle we will take tan, now see again this upon this, that is opposite upon adjacent. Again the ratio is 10. So tan 60 is equal to 1.6 plus h upon x. 1.6 plus h upon x. Tan 60 is root 3. Root 3 is equal to 1.6 plus h upon x. Cross multiply. Root 3x is equal to 1.6 plus h. We have cross multiplied. Give it 2. Give it as a 2. So we got 2 equations. One is x is equal to h and this from 1 and 2. From 1 and 2. We can replace any one value. Suppose instead of x I am replacing h. So it will in this. So root 3h is equal to 1.6 plus h. Take h one together. Root 3h minus h is equal to 1.6. Now you can see that h is common. So h common, root 3 minus 1 is equal to 1.6. Therefore, h is equal to 1.6 upon root 3 minus 1. Again you got an irrational number which should not be in the denominator. You can rationalize it. So we will rationalize it. H is equal to 1.6 root 3 minus 1 into root 3 minus 1 upon root 3 minus 1. So that will be equal to h is equal to 1.6 root 3 minus 1 upon root 3 square, that is 3 minus 1 2. So this is your, and you can write down the unit as meter. And even you can simplify 1.6 divided by 2, that will become 0.8. So your final answer will become h is equal to 0.8 root 3 bracket root 3 minus 1 meter. So we got that we got is the height of the pedestal. Same another question. A person is standing on the bank of the river. A river is flowing and a person is standing here. Suppose the river is flowing this way and the person is standing here. On the other bank there is a tree. A person is standing on the bank of the river, observes the angle subtended by a tree on the top, on the opposite bank is 60 degrees. So the river, suppose if I am taking flowing this way, person is standing here, on the opposite bank there is a tree and the person is looking at the tree. So again angle of elevation. From, he is looking at the top. So the person is looking at the top and the angle is made 60 degrees. Now he retreats 20 meters from the bank. Retreats means he is going away from the bank 20 meters. 20 meters is traveling back. And then again he is observing the tree from there. And the angle of elevation is 30 degrees. Then the angle becomes 30 degrees. Find the height of the tree and the width of the river. So see, by using the applications we can even find out the width of the river and then the height of the tree. Now suppose this is the river width. This is the river flowing this way. I am taking it as a BC. Now on this bank there is a tree. Or you can say on this is a tree, on this is the bank. The tree is here. From this point, the person is looking at the tree. Looking at the tree, the angle of elevation is 60 degrees. Looking from top or from bottom to top, so elevation. AB is the tree. BC is the width, the river which is flowing. C is the point the person is standing and looking at the top of the tree, making an angle of 60 degrees. He retreats 20 meters. So what he is doing, he is coming towards it, towards the bank, and he is retreating, he is going away from it 20 meters. And then again he is observing it. He is going 20 meters again away from the bank and then he is looking at the tree. The angle he is making is 30 degrees. Find the height of the tree. Let the height of the tree be h and the width, the river, this is the width, that is x. And you know that it is always perpendicular, so 90 degrees. It is a right triangle. Now Let AB is a tree whose height is h meter. BC is the width of the river. Which is x meter. Now first take a right triangle. Always just your eye should be on the right triangle. In triangle ABC. Triangle ABC. So I mean this you know h and this is x. So opposite upon adjacent 10. Tan 60 is equal to h upon x. Root 3x is equal to h. Therefore, you can take this as 1. You can keep it as 1. Now we will take a triangle ABM. You have retreated 20 meters, so in triangle ABM. ABM. You will forget this. Don't look at this. Just see this triangle ABM. Don't think about this. So 1030 will be equal to this. You are not looking. So h upon this becomes your adjacent. X plus 20. H upon x plus 20. That becomes your adjacent. 1030 it is 1 by root 3 is equal to h upon x plus 20. Cross multiply it. X plus 20 is equal to h root 3h. This is your 2. This was your 1 when we solved the first triangle. The second triangle we solved, we got x plus 20 is equal to root 3h. From 1 and 2. From 1 and 2. Now what can you replace? H as what? Root 3x in this. So we will write down x plus 20 is equal to root 3h. Instead of h, I can place root 3x into root 3x. So x is plus 20 is equal to 3x. Therefore, x is equal to, so root 3, 3x, 3x minus x, you will get 2x is equal to 20. Therefore, x is equal to 10 meter. That you got the, what is your x? Width of the river. So, width of the river is 10 meter. Now, height of the tree. Height is equal to root 3x. Height is root 3x. You can replace the value of x. So, you will get h is equal to 10 root 3 meter. So, that you will get 10 root 3 meter. So, I think so you might have understood it.